Okay, so let's take a look at another way we can get some information. We're given a table of data here. And they want us to determine the equation of the functions is the simplest model. So based on that, they're trying to give us a hint that maybe use a cos curve and find the first phase shift as opposed to one way down the road. Okay, so let's start off the same things we did before. A, the maximum. What's the highest that this graph goes? Well, based on our table, 21. Minus the minimum, that looks like 13, divided by 2. So we get 8 over 2, which is 4. C value, max plus min divided by 2. That gives us 34 over 2, 17. The period, well, the period is one complete cycle. So if I start at a value, I have to end on the value for a cos curve, right? So I can go from 17, and then it goes down and up again, and then back to 17. That would be one cycle. Or 13 all the way to 13, right? Based on that, it looks like a period is 720 degrees. That will help me figure out K. K is 360 over the period, over 720. I get 0.5 again. Okay, so let's make ourselves an equation. What do we need? Y equals A, 4, times your cos, times your K, 0.5 or 1/2, times your phase shift. A cos curve is supposed to start at the first maximum. Okay, the first maximum is right here at 21. But it's not at 0. It's at 360 degrees. So it's been moved to the right. Right 360. How do I show that? Well, x minus 360. And then in my C, my central axis at the end here, plus 17. And there's the simplest equation that we could make. Okay. Take a look at another one. See what you can do with this one. A sinusoidal function has an amplitude of 5, a period of 120, and a maximum at 30 and 3. They want us to determine any other key features. So what would be an important thing we know? We got our A, got our period, got a maximum. Maybe we could find the central axis. Okay, our central axis. Central axis. How do I find the central axis? Well, if I know the maximum, that's the highest I reach, and I know my amplitude is my distance from the central axis to the maximum, I could subtract that. So I could take my max of 3, subtract my amplitude of 5, and I know the central axis has been -2. Well, now that I know that, can I find the minimum? I think I probably could. My central axis minus the amplitude. So our central axis we just said was -2. We subtract the amplitude of 5, and my minimum is -7. Now I kind of have all the important parts I need to make this sinusoidal function. So let's take a second here to draw one. Okay, what do I need? What do I got? Maximum is at 30 and 3. So if I go by 30s, so 30, 60, 90, 120, 150, 180, and so on. And I know we usually go by 90s, but I'm going to draw this to whatever makes my life easier to make the equation, right? Oops, not 180, 120 there, sorry. 150, 180. Okay, my y values, I need to go as high as, we said a maximum of 3. 1, 2, 3. And a minimum of -7. 1, 2, 4, 5. I'm going to make this a little bit bigger, that's okay. 6, 7. Let's number these. -2, -4, -6. Okay, what do I know for sure, I was told we have a maximum at 30 and 3. So 30 and 3, there's a dot right there. I was told that the period is 120, which means in 120 degrees more, I'll be back to where I started. So 30 plus 120 makes 150. That's my next maximum. Where is my minimum going to happen? Well, if those are my two maxes, my minimum has to be halfway in between those two, right? So at 90 and -7, 90 and -7 down here. Okay, I'm going to label these things just so I remember what they are. 90 and -7, 150 and 3, 30 and 3. Okay, what else do I know? Well, I know there's a central axis, and it's at -2. So if I were to draw a line at -2, I know that halfway between my mins and my maxes, I should be on the central axis. So halfway between 30 and 90 would be 60. I should have a dot right there. And again, on the other side, a dot at 120. And then I can draw my curve. Okay, there's our coast curve. Okay, what were the keys there? We've got to find a min and a max. Okay, we know that the period was 120, so we can figure out the next max. Then we can find the halfway points between all those things. Okay, represent the function as a transformed sine function. Ooh, a sine function. Okay, so what do we need? For any function, no matter what, we need to know A, amplitude. We were told the amplitude in this question, though, right? Right back here at the beginning, we were told an amplitude of 5. So we don't have to figure it out. Just got to write it down. Okay, we need to know our C. We weren't told it, but we calculated that a second ago. We figured our central axis was -2. Okay, the period was 120, so we can solve for K. Sorry, K equals 360 over 120, which is 3. And now we can make our curve. Y equals A, amplitude, sine, K is 3. Is there a phase shift? Well, a sine curve is supposed to start on the central axis, the very first point, and going up from there. So it should be right here. But our first point that goes up from the central axis is way over here at 120. Okay, that's where it starts on the central axis going upwards, right? Okay, so it means it's been moved to the right 120 degrees. So in our bracket, x minus 120. And then our C value, -2. Okay, there's a sine curve. Part C, make it a cos curve this time. So the same ideas, we're just going to make it a cos curve. So what do we got? Y equals 5. That hasn't changed. Cos, that's different. K, well, that hasn't changed. Okay, is there a phase shift? Cos curves are supposed to start at the very first point on the maximum, right here. Oh, but ours has been moved over to there. 30 degrees to the right. So x minus 30, opposite sign. And C is still C. Okay, there's our sine curve, there's our cos curve. They're two different equations that represent the same function. They're just out of phase with one another. Okay, last one, word problem, application. A seagull sitting in the water rises and falls as the waves pass. A wave passes every 4 seconds, and the height of each wave from the crest to the trough, so the top to the bottom, is 0.5 meters. Let's sketch a graph to represent this over 10 seconds. Okay, so just a quick sketch. What do we know? We know every 4 seconds a wave passes. So that's a cycle, right? 4 seconds. 8 seconds, another cycle. By the time I get to 12 seconds, a third cycle. Now it wants me to stop at 10, so I have to figure out what that's going to happen there. We know that the height of the wave from crest to trough is 0.5. So if we assume, just for argument's sake, 0.5 is right here, we know that's the highest it could be, and the lowest it could be would be 0. We are asked to sketch for a 10-second period starting at the crest of a wave, at the top of the wave. So based on that, we know the seagull starting right here. And we know in 4 seconds, it's going to be back to there. That's how long it takes for a wave to pass. And 4 seconds more, back to there. Right? And what should happen in between? Well, at the halfway point, it should be at the minimum. At the halfway point, it should be at the minimum. And at the halfway point, which would be 10, it should be at the minimum. So based on that, I can draw, oops, that's a little messy there, but it's okay. My curve. Okay, this would be my height, and this would be my time. And then part B, find ourselves an equation to model this. We can figure out our parts and pieces. What do we need? We need an A. A is max minus min. We picked some nice numbers here this time, right? Just 0.25. The nice thing with this one is I do max plus min, which is the same thing. Our period is 4 seconds. So if I want to find k, I can take 360 divided by 4, which is 90. Okay, our equation, y equals a 0.25 cos k. Is there a phase shift? Well, we're supposed to start at the maximum going down. It kind of looks like that's what this point is. So no phase shift there. Don't really need this bracket. I can put our x in there. And then our c, 0.25. There's the equation of that model. Okay, that takes us to the end of today's lesson. Try the homework. There's not going to be a quiz today, but tomorrow there's that mid-chapter assignment you should try and work your way through. It's pretty short, this one, so the quicker you can get in, the quicker you can get back to you, and then we can move on to the test.